afternoon. We are welcome the delegation from Shanghai. We have the pleasure of receiving So we have the pleasure of receiving the delegation from Shanghai today at the IAFE. Today will be a colloquium given by three parts. The first part will be given by Dr. Chen, who is the Vice President of the Shanghai Association for Science and Technology. Then the second part will be given by in virtual way, remotely, by Dr. Peng Jiang, who belongs to the Center for Space Physics and Astronomy, Polar Research from the Institute of China. And the third part will be in person, and we have a pleasure to receive the Professor Chenggang from the Shanghai Key Laboratory for Astrophysics, Shanghai Normal University. So welcome to the Chinese delegation. Thank you.
哭不成，你看得见吗？
我可以，
我可以啊。哦 ，OK。
Translate your
Yeah.
talk. Okay. So I'm going to give you this one because John Williams. She's the translator.
Well. 好了。女士们、先生们，大家下午好！感谢阿根廷的组织给我这个演讲的机会，非常荣幸跨越山海，来到美丽的布宜诺斯艾利斯，与各位相聚在这所享有盛誉的百年学府。
Señoras y señores, estimados y estimadas, buenos tardes. Ahora nos alegra que el Instituto de Astronómico y la Universidad de Buenos Aires tiene una oportunidad de presentar nuestra organización, la Asociación de Ciencia y Tecnología de Shanghai.
今天很高兴能有这样的机会，向大家介绍一下，我们这个来自上海的科技组织——上海市科学技术协会，以及我们在连接科学家、连接世界、连接未来方面所做的努力和实践。希望能为接下来的交流和合作做一个好的开始。
Espero que esto pueda ser un buen comienzo para los próximos intercambios y colaboraciones y nuestro esfuerzo y prácticas en conectar a los científicos, el mundo y el futuro.
再回过去一下，刚刚第一张，这张照片是我们工作的场所。
Esta foto es la dirección de nuestro trabajo.
好分。上海市科协成立于1958年，是上海自然科学与工程技术领域最大的科技工作者组织，也是推动上海科技事业发展的重要的社会力量。
La Asociación Ciencia y Tecnología de Shanghai se estableció en 1958 y es la mayor organización de trabajadores de la ciencia y la tecnología en los campos de las ciencias naturales y la tecnología de ingeniería en Shanghai.
我们拥有管理290多家科技类的社会组织，覆盖40多万名专家会员，学科涵盖自然科学与工程技术的各个领域。
Poseemos más de 290 organizaciones sociales, más de 400,000 miembros expertos abarcando disciplinas en todas las principales áreas de las ciencias naturales y la tecnología de ingeniería.
我们的组织网络遍布上海16个区、17所高校以及267个科技园区和企业。
La red organizativa se extiende por los 16 distritos de Shanghái, 17 universidades y 271 parques tecnológicos y empresas。
我们核心的使命可以概括为4个服务：服务科技工作者，服务创新驱动，服务公民素质的提升，服务公共科学决策。
Tiene 4 servicios importantes: servir al desarrollo impulsando por la innovación, servir a los trabajadores de la ciencia y la tecnología, servir a mejora de la alfabetización científica de los ciudadanos y servir a la toma de decisiones científicas públicas。
2021年，习近平主席对科学工作定位提出了新的要求，要坚持面向世界、面向未来，增进对国际科技界的开放、信任和合作。
En 2021, el presidente Xi Jinping planteó nuevos requisitos y enfatizando que deberían mirar al mundo, mirar hacia el futuro y aumentar la apertura, la confianza y la cooperación con la comunidad científica internacional。
这句话正是我们开展国际交流的根本指引，也是今天我们来到这里的原因。
Estas palabras son justamente la guía fundamental para nuestro intercambio y la razón por la que estamos aquí hoy。
而支撑我们践行这一使命的是覆盖全学科领域的209家学会。
Tenemos 209 asociaciones que cubren todos los campos。
它们涵盖高端装备、智能制造、生物医药、健康产业、先进材料、绿色能源、信息技术、人工智能等各大门类，集聚了上海顶尖的科技人才和创新资源。
incluyendo el manufactura inteligente, biomedicina e industria de la salud, materiales avanzados y energía verde, tecnología de la información y inteligencia artificial, etc.
UBA 是一所学科门类齐全的综合性大学。接下来的介绍也许会让各位感到，在许多领域我们早已是同行。
La Universidad de Buenos Aires es una universidad integral con una amplia variedad de facultades. Quizás sea introducción siguiente, todos sientan que en muchos campos ya somos compañeros。
好的，接下来我重点介绍几个与 UBA 优势学科高度相关的学会。
A continuación voy a presentar algunas facultades de ventaja de la UBA。
这个是上海市医学会，学会拥有288家单位会员，2.2万余名的个人会员，下设92个专科分会，全面覆盖临床医学、基础医学、公共卫生、药学、医学工程等领域。
Esta es la Sociedad Médica de Shanghái y cuenta con 288 miembros corporativos y más de 20.000 miembros individuales con 92 divisiones especiales, incluyendo la medicina clínica, medicina básica, salud pública, farmacia, ingeniería médica, etc.
学会编辑出版7种期刊，持续打造东方系列的国际会议，已经成为中外医学技术交流的标杆平台。
La sociedad publica 7 tipos de revistas, desarrolla una serie de conferencias internacionales orientales que más muy importante del mundo。
下一章，上海市畜牧兽医学会，学会设立有6个工作委员会、8个专业学组和3个专业分会，全面覆盖畜牧养殖、疫病防控、兽医诊所、公共卫生等全产业链。学会设有国际国内交流学会，长期开展国际学术会议、专家互访、技术合作，定期主办兽医科技发展国际论坛，是中国华东地区这个领域重要的国际盛会。
Eso es la Asociación de Medicina Veterinaria y Ganadera, La asociación ha establecido 6 comités de trabajo, 8 grupos de estudios profesionales y 3 ramas profesionales, incluyendo ganadería, control de enfermedades, diagnóstico y tratamiento veterinario y salud pública. Regularmente organiza el Foro Internacional de Desarrollo de Tecnología Veterinaria y el Foro de Salud Pública en China。
下一张，上海市计算机学会，学会设立了20余个专业委员会和工作委员会，覆盖了计算机基础理论、底层的软硬件、大模型、计算机视觉、网络安全、行业数字化等传统与前沿的方向。
Eso es la Asociación de Computación de Shanghai y ha establecido más de 20 comités profesionales y comités de trabajo, cubriendo áreas tradicionales y vanguardia como teoría básica de la informática, hardware y software de bajo nivel, grandes modelos, visión computadora, etc.
专业的。第4个学会是上海市气象学会，学会设立有城市气象与灾害预警、生态与农业气象、气候变化与极地气象等9个专业委员会，覆盖了气象全链条的业务及前沿的调查领域，依托与多国气象机构与高校的长期合作，主动承接世界气象组织7项国际示范项目，形成了台风预报算法、数据集成等成果，确立了亚太区域台风预报检验的主导地位。学会还主导联合研发了妈祖大模型，已在蒙古、吉布提等35个国家和地区试点应用。
Eso es la Asociación Meteorológica de Shanghai y ha establecido 9 comités especializados sobre meteorología urbana y alerta de desastre, meteorología ecológica y agrícola, cambios climáticos y meteorología polar, etc. Y ha asumido activamente 7 proyectos de demostración internacional de la organización meteorológica mundial. Han generado logros como algoritmos de predicción de tifones y conjunto de datos en la región Asia-Pacífico, y tiene la gran modelo MASU, que ya ha aplicado de manera piloto en 35 países como Mongolia y Djibouti。
以上4家学会只是上海市科协209家学会中的一部分代表，但是从中也可以看出，我们在生命科学、数字技术、人工智能、环境生态等领域都拥有扎实的基础和资源。UBA 在这些大类的学科方向上同样的积淀深厚，实力突出。我们非常期待双方能以相关的学术领域为纽带，在学术交流、联合研究、人才互访等方面探讨合作的可能性。
Las 6 sociedades mencionadas anteriormente son solo una parte de las 2009 sociedades de la SAST, y esto se puede ver que tenemos una base y recursos sólidos y ciencia de la vida, y la Universidad de Buenos Aires también tiene un sólido desempeño en estas áreas. Esperamos explorar la posibilidad de cooperación e intercambio académico en el futuro。
在了解了我们的学会资源之后呢，接下来我想借今天这个宝贵的机会，重点分享2项我们的工作，一个是面向国际的高端的学术交流，另外一项是培养青年科技人才。
Y voy a compartir 2 casos importantes de nuestros trabajos. Uno es el intercambio académico de alto nivel internacional y otro es la formación del talento en ciencia y tecnología。
首先介绍一下几个近年来我们重点开展的学术交流活动。第一个是世界顶尖科学家论坛，我们已经连续8届参与举办世界顶尖科学家论坛。这个论坛吸引了全球诺奖、沃尔夫奖、图灵奖得主等顶尖科学家参与。 其中第4届2021年的共有131位顶尖科学家参会，其中68位诺奖获得者来沪参会，规模创历届之最。
Hemos participado en la organización de Foro de Científicos de primer nivel del mundo durante 8 ediciones consecutivas. Este foro ha atraído a destacados científicos de todo el mundo, como Premio Nobel, Premio Wolf y Premio Turing, y tiene una participación 131 científicos de primer nivel y 68 ganadores de Premio Nobel en el foro de 2021。
论坛还设立了顶尖科学家的协会奖，分设数学与智能科学奖和医学与生命科学奖。
El foro también establece el premio de la Asociación Mundial de Científicos de primer nivel, que incluye 2 premios y cada premio es de 10 millones de yuanes chinos y aproximadamente 1,5 millones de dólares。
这里还有一个好消息，就是2026年的论坛将增设青年奖项，我们也非常期待看到来自阿根廷、来自 UBA 的青年才俊一起参与我们这样的盛会。
Y en el año hoy, el foro añadirá un premio para jóvenes y esperamos con especial interés ver las jóvenes talentos de Argentina de la Universidad de Buenos Aires。
我要介绍的第2个会议是世界人工智能大会。我们上海市科协自2020年起呢，负责大会的优秀论文奖的评选，主要是面向全球40岁以下的青年科学家。
El segundo premio es la Conferencia Mundial de Inteligencia Artificial, una de las conferencias más grandes del mundo en el campo de IA. Desde 2020, el SAST se encarga de la evaluación de premios a los jóvenes científicos sobresalientes de la conferencia, dirigido a científicos menores de 40 años de todo el mundo。
下一个要介绍的是去年我们承办的世界工程组织联合会全体大会。去年10月呢，在上海举办。这是世界工程组织联合会，是联合国教科文组织倡议支持下成立的，是全球最大的工程类的非政府组织。
En el año pasado de octubre, el Congreso Mundial de Ingeniería y Asamblea General se celebran en Shanghai, que esta es la organización no gubernamental de la ingeniería más grande del mundo, establecida con el apoyo de la UNESCO。
大会以工程塑造绿色未来为主题，来自65个国家的工程组织760位代表参会。
El tema es la ingeniería dar forma a un futuro verde y tiene participantes más de 700 personas y organizaciones de ingeniería más de 65 países。
这次大会上有一个创新的亮点，就是首次设立的工程能力工作坊。我们从海陆空第4个维度，围绕城市更新、资源再生、智能建造、航空制造、海洋装备、轨道交通、绿色能源7个领域，精选了13个标杆工程场景，邀请各国的外宾走进工程一线，近距离地了解工程实践的上海方案，感受中国创新的理念和魅力。
Un aspecto innovador de esta conferencia importante es la primera vez de la taller de capacidad de ingeniería desde 4 dimensiones de mar, tierra, aire y suelo y un torno de 7 áreas, por ejemplo, renovación urbana, reciclaje de recursos, transporte ferroviario y ingeniería verde, y seleccionaron 13 escenarios de ingeniería, invitado a los visitantes extranjeros a participar a primera línea de la ingeniería y experimentar la filosofía y atractivo de Shanghai。
这些照片是 我们全球的工程师参观现场的一些留下的照片。
Estos fotos son los participantes de la feria.
翻译。这次大会给与会的外宾留下了深刻的印象。我们通过采访了50位的与会的外宾，打造了全球工程师看上海的专栏的报道。
A través de entrevista, invita 50 invitados extranjeros asistentes y creamos la columna especial Ingeniero Global en Shanghai, registrando sus sentimientos sobre la innovación de China.
全球的工程师们表示，通过这次大会，他们看到了一个真实、立体、创新的上海。
Estos invitados dicen que gracias a estas conferencias pudieron ver un Shanghai real.
此外呢，我们的学会也主办了非常多的具有国际影响力的品牌活动，覆盖了医学、海事、航空、极地等多个领域。
Además, nuestra sociedad también organiza numerosos eventos de marca con influencia internacional, con muchos ámbitos.
比如说，稍后即将与大家交流的中国极地研究中心，就作为上海市航海学会和上海海洋湖沼学会的会员单位，在2024年的10月，在我们的工作场所上海科学会堂举办了中国极地考察40周年的国际研讨会。
Por ejemplo, el Centro de Investigación Polar de China, que comunicará con todos más adelante y es miembro de la Sociedad de Navegación de Shanghai y de la Asociación de Oceanografía y Limnología de Shanghai. Y en octubre del año pasado, el Salón de Ciencia de Shanghai, el Seminario Internacional de 40 aniversario de Exploración Polar China.
来自24个国家和地区的271位中外专家齐聚一堂，深入的交流极地研究的前沿成果。
Y tiene más de 24 países y más de 260 expertos chinos.
下一页，这是我们船舶与海洋工程学会主办的中国海事技术学会和展览，已经成为全球规模最大、最具影响力的顶级海事盛会。自2019年开始，一直是蝉联这个世界第一。
Por ejemplo, esta es la Conferencia Académica y Exposición Internacional de Tecnología Marítima de China, que es el más grande y más importante desde 2019.
就在去年的12月，吸引了来自40多个国家和地区的2200多家知名企业参展，境外展商占比达43%，接待了全球139个国家和地区的超过10万名专业观众。
En diciembre del año pasado, se ha traído más de 2.200 empresas conocidos de más de 40 países y más de 100.000 visitantes profesionales y 139 países y regiones de todo el mundo.
科技期刊也是我们开展国际学术交流的一个重要的平台。目前呢，上海有390多种科技期刊，其中英文期刊有112种，35种进入 Q1 区，12种影响因子学科排名全球前5%。
La revista Científica y Tecnología es también una importante plataforma y con más de 390 revistas científicas y tecnología, de las cuales 112 con revista en inglés, 35 están en el área Q1 y 12 tienen un factor de impacto de la sitúa en el 5% superior a nivel mundial en sus disciplinas.
我们创办了上海科技与期刊高质量发展大会，联动了近100家的科技期刊与头部的出版机构，围绕前沿议题展开深度对话。
Fundamos la Conferencia sobre el Desarrollo de Alta Calidad de Ciencia, Tecnología y Revista de Shanghai y investigar en profundidad los temas de vanguardia.
同时，我们依托一批高水平的期刊发布 激光科技前沿20问、核科技前沿10问等引领性的议题，发挥期刊在学术前沿的导航作用。
Publicamos temas como bien de preguntas sobre la vanguardia de la tecnología láser y 10 preguntas sobre la vanguardia de la tecnología nuclear.
下一页。通过开展这些学术交流活动，我们也感受到越来越多的青年科技人才正在快速的成长。为了帮助他们走向舞台的中央，我们同样关注青年科技人才的教育和培养。
Podemos ver cada vez más jóvenes talentos en ciencia y tecnología están creciendo rápidamente y también prestamos mucha atención a la educación y formación.
同时，我们还组织优秀的青少年参与世界顶尖科学家论坛、国际的科学赛事，拓展他们的全球视野，定期举办公共实验屋、家门口的科学社等特色活动。
También organizamos que jóvenes destacados participen en foros con los científicos más importantes del mundo y celebramos regularmente actividades especiales como casas, experimentos públicas y sociedad científica en la puerta de casa.
2024年，我们把承载科学传奇的牛顿苹果树引入上海科学会堂，如今它已经成为青少年体验科学的标志性的场景。
En 2024 introdujimos en el Salón de Ciencia de Shanghai el manzano de Newton.
翻译。在更高层次的人才培养上，我们实施了博士生的专项培育计划，覆盖了理工、农医和交叉学科。我们聚焦学术提升、实践锻炼、国际交流等目标，邀请院士、权威专家、国际出版机构的高管为博士生提供指导，还组织他们参与论坛、产业调研、国际访学等系列活动，帮助青少年拓宽视野、锤炼能力，在开放合作中加速成长。
En el nivel superior de formación de talento, hemos implementado un programa especial de desarrollo para estudiantes de doctorado que abarca ciencia, ingeniería, agricultura, medicina y disciplinas interdisciplinares, etc. Nos centramos invitando a académicos, expertos reconocidos y altos directivos y editoriales internacionales para guiar a los doctorandos.
有了前面的了解，最后我想谈一谈我们已有的国际合作的基础，以及面向未来，特别是面向 UBA 的合作愿景。
Y con la comprensión anterior, finalmente quiero hablar sobre la base nuestra cooperación internacional existente con la Universidad de Buenos Aires.
近些年，上海市科协一直在积极拓展国际朋友圈。比如说，2023年，我们与纽约科学院签订这个合作备忘录。
En los últimos años, la SAST ha estado activamente expandiendo su círculo de amigos internacional y en 2023 firmamos un memorando de cooperación de la Academia de Ciencias de Nueva York.
今年9月份，我们将在纽约共同举办新一代癌症治疗技术的学术会议。第一届是2024年，我们在上海科学会堂举行的。
Y este año organizaremos conjuntamente en Nueva York la conferencia académica sobre nueva tecnología de tratamiento de cáncer y el año pasado se organizamos en Shanghai.
此外，2024年我们联合英国国家信托基金会把牛顿苹果树引入了科学会堂。
Y en 2024, en colaboración con la Fundación Nacional del Reino Unido, introdujimos el manzano de Newton en el Salón de Ciencias de Shanghai.
南美大陆一直是我们重点对接的区域，我们支持上海师范大学建成市属高校的首个院士工作站，开展亚毫米天文探测研究。 依托 LCT 项目持续推进与智利高校的科研协作。稍后他们也将进行交流发言。今年1月，智利康塞普西温大学的天文团队访问上海，亲身感受了这座城市的科创活力。我们也真诚欢迎更多的拉美科研团队前来交流。
El continente sudamericano simple es una región clave con la que nos conectamos. Apoyamos a la Universidad Normal de Shanghai para establecer la primera estación de trabajo de académicos en universidades municipales, llevando a cabo investigaciones de detección astronomía subminimétrica y con base con el proyecto Legenden Telescopio continuamos promoviendo la colaboración científica con universidades chilenas. Más adelante también realizarán presentaciones de intercambio. En enero de este año, el equipo de astronomía de la Universidad Concepción en Chile visitó Shanghái y experimentó la primera mano de la vitalidad científica y tecnología de esta ciudad. Damos una sincera bienvenida a más equipos de investigación de América Latina a venir y participar en intercambios.
这个是我们大歌剧院，这个是温室花园，这是我们的科学会堂。
Esto es la gran museo y la fero de nuestras vistas.
下一页。近年来，我们也积极的欢迎并支持国际科技组织落户上海，致力于为全球的科技交流与合作提供开放便利的环境。目前，上海市科协已经有3家主管的代表机构。我们还在跟多家的国际组织积极的接洽当中。同样，真诚的欢迎来自阿根廷的科技组织在上海设立代表机构并开展合作。
En los últimos años hemos dado una cálida bienvenida y apoyo a la instalación de organizaciones científicas internacionales en Shanghái. Ahora existen 3 representaciones de organizaciones extranjeras bajo la supervisión de la SAST y damos una sincera bienvenida de la Organización Científica de Argentina para establecer representaciones o llevar a cabo proyectos de cooperación en Shanghái.
关于合作愿景主要是2个方面，一是推动相关的一些专业学会跟 UBA 的优势学科开展对口的交流。
Esperamos explorar la cooperación en los siguientes aspectos. Primero, promover el intercambio específico entre las sociedades académicas relevantes y las disciplinas de ventaja de la Universidad de Buenos Aires.
另一方面，我们期待 UBA 携手，共同为青年学者和学生搭建交流实践的平台。
Y segundo, promover conjuntamente el crecimiento de jóvenes talentos en ciencia y tecnología.
最后，请允许我回到开篇的关键词：开放、信任、合作。
Por último, permítanme repetir las palabras clave: apertura, confianza y cooperación.
上海市科学院成为连接上海与布宜诺斯艾利斯、连接中国和阿根廷科技界的一座桥梁。跨越山海，我们为合作而来，面向未来，我们愿携手同行。
La Asociación Ciencia y Tecnología de Shanghái desean ser un puente que conecte Shanghái con Buenos Aires y China con la Argentina, cruzando montañas y mares. Venimos por la cooperación de cada futuro. Deseamos caminar juntos.
感谢各位的聆听。
Gracias a todos por escuchar. Gracias. Gracias.
Perdón. Thank you. Question at the end. ¿Estamos listos? Sí. Sí. Bueno, ahora vamos a escuchar al doctor Peng, que está de manera virtual. Sorry, I'm speaking Spanish.
Oh, sorry. Yeah. 现在好了吧？喂 Okay, I think right now you can hear me. All right, so I will. Okay, very good. Dear colleagues, I'm here following the presentation by Dr. Chen. Right now, I will spend some time to go detail into the Antarctic autonomy at domain. First, I will. Yeah, I forgot to introduce myself. I'm Peng from Polar Research Institute of China. Our institute is in Shanghai, so we have a very good collaboration with the university and institute in Shanghai. First, I will talk about a little bit on the Antarctic autonomy. As Antarctica has very promising sites for astronomical observation. So Antarctic autonomy is actually a very important field in polar research. Here, I list two questions. Two questions for Antarctic autonomy, and it was defined by the scientists and the government policies in SCAR meetings. First, the question is what happened in the first second after universe began, and have another question: what is the nature of that university and how it is affecting us? We hope using the very clean sky in Antarctica, we can answer these questions by observing. This is on the milestone of Chinese expedition in Eastern. Uh-huh. Really? Sorry. Yeah, I try to. Oh, I see. My presentation was frozen. It's moving? Yeah, yeah, yeah. So I think, all right, let's do it in this way. Yeah. So this is the milestone of China's expedition in Eastern Antarctica. So Chinese expedition team arrived Antarctica first time in 1984. Yeah. So it almost is over 40 years. 40 years before after the we do Antarctic expedition. The site for autonomy actually is domain. Domain is the highest point on Antarctica glaciers. So it's very with a highness of over 4 kilometers. China's expedition first arrived Domain in 2005, and during the IPY4, we try to establish a station and do astronomical research over there. So 4 years later, in 2009, the Kunlun station at Domain was established, and we have a very good platform for astronomical observation over there. Oh, sorry, it's still Sorry, it's further again. Why it cannot moving? Oh. Yeah, stay in the same page, right? I was trying to figure out how. All right, I see. I should do it on my own presentation, not on the screen. Right. Sorry for that. I get it. Okay. So here is the map of Antarctica overall, and right here is the domain. So it's about 1,200 kilometers from our Zhongshan station on coast. So every season we take a shallow icebreaker from Shanghai to Zhongshan station around here, and we drive we drive a very long distance on the ice shear to Domei. So using the data we collected in almost 20 years, we identify Domei has very nice conditions for astronomical observation. First, it has a very good seeing, and this is a paper published in Nature said Antarctic site could offer Earth's clearest view of the stars. And besides in optical, Domei also have uh, very good conditions for terahertz and far infrared windows. So and this windows actually last for the all year round. It's even better than the site of Amma. Right now, we operate a half-meter optical telescope and at Domei remotely, and because this site is actually very cold, very cold. In winter, the temperature is 80 degrees. It's almost in winter. We don't start in winter, but our telescope works there. Works there. Um, this is electronical power platform. It will provide power and satellite connection for our telescope, and we can access the telescope very easily and get the data soon after observations. And this is the buildings on the on Kunlun Station. On Kunlun Station, we our expedition team members live in these buildings in summer. But yeah, it's very difficult for people to work there. So every year in the Antarctic summer, we spend about 4 weeks at Kunlun Station to maintain our telescope and to update some instrument there. It's very short working windows. This is an overview, a bird view of the astronomical site in Kunlun Station, and we can see now we have some more instrument there, and this is the half-meter telescope I just mentioned before, and here we have a small near-infrared telescope. Earth's sky is very blue in Quantum Station. So so in daytime we can observe. And so this is the Seeing telescope. The Seeing telescope. We keep monitoring Seeing at domain to identify the observational conditions there, and this work will keep about 5 years. Here I want to bring up the IPY5. This is about 25 years after IPY4, because the Antarctic autonomy in China was began from IPY4. So after 25 years efforts, we want to bring up more big signs in IPY5 to develop more large telescopes can observe at Quantum Station. And we also now the project was in planning stage. So we have about 5-6 years way to the IPY5 summit year. So we have still have some time to develop this big science project. And we want to design the project as an international collaboration project. And so I personally welcome all the astronomer in Argentina can join us, and we can share the telescope in Antarctica, and we can share the data we get there. I think it is a very we can have very good collaboration, because we both Antarctica and Argentina both in the south. We can observe south hemisphere together, and so we have. I think we can do very good job. We can do very good job together. All right. So I would like to stop here, and if you have some questions, we can discuss later. Thank you very much.
Talks to okay. So it works or not? Okay. So how to control that? Left and right, right?
Yeah.
This one. I see. Okay. So I would like to thank your director to invite me here to present the talks, to give you a brief introduction of the work in the teams in Shanghai Normal, because we are too far away from each other. So maybe you know less about Chinese astronomy, especially in Shanghai. Okay, so I would like to go a little bit fast. So due to the time is limit. So it's a general information is for my team is my team is established the first actually in Shanghai universities. Originally, there are a lot of astronomers were working in the observatories, not in the universities. Now at that time during 2004, I established the first team in universities. Now we have several teams in different universities. So currently we have 24 staffs, including one secretary. Totally the mean age is 42. It's quite young. I'm the second oldest one. Okay. The field is including some cosmology and galaxies and AGNs, instrumentations in some millimeter and some millimeter in this field. Okay. In this, the lab, actually, our team is belong to the School of Math and Physics, usually like here. But we are very independent, mainly because of the maintenance of the running of the field. We are doing by ourselves. So we don't have the undergraduate programs. We don't have undergraduate students. We have only master degree and PhD degree students and a postdoc. Usually every year, we have master degree student for number of 8 and PhD something like the 6 and postdoc almost 3 because we don't want to use a lot of money to waste up like this. So we don't save money, but we can provide very cheap dormitory with very good conditions, by the universities. We have something like called the provincial level platform. That's what we call the labs to support from the government. One is it's a local government, of course. I mean Shanghai. One the first is the Shanghai Key Lab for Astrophysics. It's founded by since 2004. The second is so-called Shanghai International Joint Lab for China and Chile's millimeter astronomy, especially for this the future the forthcoming some millimeter telescope. These kind of two labs are supported by the Science and Technology Commission of Shanghai municipality. The third is I would like to thank the Shanghai Association for Science and Technology that they support me academia for academic thing we call Shanghai's workstation. He's the academic thing for Chinese in China. We have especially some workstation for him. The fourth is supported by the Education Commission of Shanghai Municipality, something called the Shanghai Research Center for some millimeter astronomy. That's very quite new. Okay, but we got the money. Okay, so I would like to let you know the funding, where the funding come from. That's very important for us. We are researchers. We need money from the government and from anywhere we can. So we have two levels, two funding from the national level. One is we call the Chinese National Science Foundation. Usually we name it NSFC. I list here. Sorry. Oops. Yeah. Too fast, maybe. Yes, here. We have several, levels of support from NSFC, so-called the Young Scientist Fund. I mean, like $50K US, roughly 3 years. The general program is under 100K, and then the key projects, I mean, 500K. This is for the maintenance of the, for the length of the year. And also we have another national level, we call it National Key Research and Development Program of China. It's a little bit, bigger. We call something like comparable to the U.S. mid-scale, NSF funding, to 1 to 3 million, lasts for 5 years. So all kind of this, support. Actually, my team we have currently in hand. So I would like to say, actually, very honestly speaking, that only something like 10 to 20% of the people can get the support from the government level. So my team, everyone has got this kind of support individually. So my team, relatively speaking, is still a little bit very compatible. And for the provincial level, Shanghai, they also can get something that is relatively the same size but different names. Okay, but here it's much rare. Much rarer we get, than the national level, because of the Shanghai government always want to focus on the economy. You can understand this. Oops. Yeah, for international collaborations, we have some exchange agreements with something like CFA, Harvard, Caltech, UMass, UC Santa Cruz, is USA, and Max Planck Institute, Heidelberg University from Germany, and also EIP, CNRS in Paris, France, also UDEC in Chile. What do I mean? For this kind of with exchange, agreement means that the other side will give us the support, financial support, mainly for the exchange students and for junior faculties, young faculties, to establish, to some future work collaborations or something like that. So, but without that, we have to prepare the money by ourselves. So, I mean, Manchester University, Barcelona, or Mexico, the universities. So that's quite a lot. I don't want to, but we have this one, something expired, agreement expired. I don't want this to here. So now let me go to my scientific research of my team. The first is we call it gas formation evolution. I just listed several. What I'm thinking about is a very good result we obtained. The first is we have proposed a model based on Kendall's observation called Kendall survey. How a galaxy evolved. This is the modeling based on observations, something like this. You can see that the Milky Way is here, located here. It is diagram. See, it's a black hole, mass, and then this is the surface density within one kiloparsec, the surface density of stellar surface density. So that the Milky Way galaxy is something like star-forming gas will evolve along this way, and then whenever its black hole, increased, reached to 31, it will immediately quenched. So this is a model prediction. It's already been approved by several observations surveys later. This paper is I prepared this paper for almost 5 years and then finally published. It's a very long paper. And after that, we also measure that coal gas, how the coal gas evolve, affect that evolution of massive galaxies. Now, only that the massive galaxy can measure the coal gas fraction more accurately. So this paper is published by Nature 2 years ago. And we finally found that black holes regulate the evolution of galaxies. The paper is listed here. You can, if you are interested, you can read this paper. I refer you to this paper. And also, currently, we are focusing on the hot gas, so-called galactic medium, the props. We want to do this. That's really because that is the first scientific target for LCT telescope, sub-millimeter telescope. So this is, the preliminary result we obtained here is by a PhD student here. He got a result of something like the Y 500, within the radius of 500 critical density as a function of stellar mass. This line give us a very clear, that's something like we call a power law. The self-similar evolution track is for a cluster of galaxies, but we measure for down to the stellar mass something like 10 to 10 solar masses. So then we look at galactic scale to the field galaxies, not the cluster gases. So there's a change a lot. This, this reflect that there's some feedback process during this evolution of these kind of galaxies. Also, we're based on these very high, accurate simulations. Sorry, I missed a TNG. I missed a character T here. TNG is 300 for cluster. We test, the K as the effect. Even that this K as the effect is even order of magnitude lower than this thermal as the effect. So the paper also published here. And furthermore, that currently AI is very modern fashion for in our astronomy. I show you several important results here from my team. The first is we call the retro estimation for the machine learning, and we adapt some so-called template perturbation optimizing method, and then together with a lot of machine learning models, we will find that the outliers will significantly decrease from 4% to something like 2%. This is very, significant, especially for the survey, very deep survey. Now, also we can provide this kind of, PDF for the material relationship pre-PDF functions to give quantitatively speaking for the error estimate for this one. So this I show you the paper is here, something here, from theory to the to the observations applications, all here. In secondly, we also use this kind of machine learning to enhance that detection for the images for super high resolution. Because for instance, we compare the Stone Digital Sky Survey's results with the DESI and HSC. If they combine together, we will get more accurate. So you can see that originally the data, the image is here, but after machine learning, you will get this with high resolution, super resolution images here. This is something like comparable to the DESI and Euclid, even Euclid launched just 2 years ago. Interesting, like very interesting, because AI can be very efficient to find some rarely very rare objects. Rare it means compared to other usual galaxies, some strange things to classify that's the evolutionary status during its whole evolution life. So for instance, we can automatically pick up a lot of galaxies, ring galaxies, automatically by this kind of machine learning, and also some identify that's the land spheroidals that you can find. Or it's very strange. It's spheroidal. It should be some quantum galaxies. Without its dust should be homogeneous distribution, but now we find there's a dust land. Why this kind of dust land coming from? This is challengeably speaking is how we can mechanism this. It's a still open question. Okay, so the paper is also here. It's just published last year. And second important work is for my team is for the cosmology. Is we mainly focus using on weak lensing, cosmic shear measurement. From this paper, for 2008 to 2020, for instance, this is very initial paper, the first paper to measure the cosmic shear in the linear scale in the world, based on the CFHT, legacy survey. It's down. You can see that the scale is very large to almost 4 arcminute. This is the first paper, for I would like to say to measure that the cosmic shear in linear scale. This is already, in if you have chance to the railway station in Paris, this is a very big advertised in Paris, to say Chinese people make this big progress at the time. And secondly, together, based on this, after 2 or 3 years, together with the new data, they make the first paper for 2 or 3 point correlation function for the cosmic shear. This is not easy to measure correctly. So this is also first paper to measure 2 point or 3 point correlation function for cosmic shear to measure to constrain that cosmological constant and the other parameters together. Okay, so now this kind of methodology, we apply this to the Chinese, Chinese we call CSST, Chinese Space Station Survey Telescope. It's scheduled to be launched at the beginning of next year, but it has been postponed for several years already. But I think it will be launched in the next year. Definitely, we'll have some command from the central government say, oh, you have to finish it, something like that. This is a 2-meter telescope in the sky. It's comparable to the Euclid for European telescope, 2 meters. Also we will observe that half of the sky coverage, something like that. And then this kind of method is actually a very useful method to make the detection or how to say that is to criteria for the mock catalog how this kind of space telescope can measure for the cosmology, so for simulations to test. Okay, so my team has done a lot of job for this kind of mock catalog. And the third is for AGNs. We know AGNs are everywhere. So we have several people doing AGNs for especially focusing on its, kinetic, how this, absorption line and emission line to get this inflow and outflow information for the gas. So you will see whenever towards you or far away from you, you can from absorption line and emission line. We have paper published here. And also you can estimate from there something like the Milky Way dust grains, because of the dust, it could be different from here and there, from place to place. It's very hard. So if we can use some important line here, something like this absorption pump in the crystal spectrum, we can measure something like Milky Way type, dust grain, the properties. So paper also published in recent years. Also, currently we also have one guide in my team is for ultra fast outflows. That's very fast objects of outflows. Why these kind of objects can move so fast? There's a physical mechanism is to be studied, mainly based on simulations. And this is a very small scale, something like several hundred times of the radius of the black hole. You can see that the result for the simulation. And this is some serious paper for the AGN, magnetic driven, ultra fast object. The mechanism is also a serious paper for this kind of series. And now let me go a little bit detail for the telescope. Maybe you are very interested in this one. We call this telescope is a Leighton Janoto telescope. Janoto is a platinum in Chile. It's one of the best single dish millimeter telescope in the world. Actually, originally it called CSO in Hawaii. A lot of people has been there, I guess, because it did, there's at that time the Caltech had they can get a lot of funding to for the maintenance, but the telescope is very good, high quality. So the three parties, Caltech, Shanghai Normal, and UDEC, University of the Concepcion, we sit down together and to discuss and make final agreement on to move this telescope from Hawaii. I'm sorry. Let me from Hawaii to Chile. Okay, to this higher side. Okay, just the other side, just the ARMA campus, outside ARMA campus a little bit. Okay, so here I show you a picture of Chinese telescope from the ground base to the sky. Okay, so we have actually you can see we have from radio telescope here and some X-ray gamma ray telescope, some satellite in the sky already, but we still lack of one. This is empty, some millimeter. Some millimeter is really, really hard for a detector, even the telescope made. It's very hard. It's just between in the radio telescope and optical telescope. It's not easy. So we are now working for this. Okay. So now the project actually started from the end of the 2019. I took my team working for remove that this CSO at the starting of this point, but I took them back to China for the Chinese New Year. The crazy that COVID happened. 2020. So everything was stuck there, even till the end of 2023. 4 years delay. So we restarted work, for 2020, and you can see that before the May, before May of 2024, the CSO is still here. After that, if you now go to the Hawaii to the Hilo, you will not find here. It's already disassembly. Okay, I finished all the infrastructure there back to the same as required by the U.S. law. And then shipment is ready at that time. It's 2024. It's in Hawaii, but we still need that the government decree, president's decree to get this tax-free into Chile. So this kind of things we wait for almost 2 years. And finally, we get this decree in 2025, last year, October, and then make this reliable, to ship that, everything to Chile. And then this year, in February this year, we start to go from Hilo, and then you can see that truck. There is cargo here, and arrive in mid-April, and everything is now in OSF or AMA. During this period, we have done a lot of things for the site surveys. This is required by the law, Chilean law. As it's also finished. So this including geotechnique study, flora and fauna, and archaeology and topographic surveys for everything we have to do for the site. This finished. You can see the people we are doing here. Now this picture is the last year where the LCT will be. This is CMBS4 and Simon's Observatory. We will locate in the other side of the row, the other side of the row of Simon's on CMBS4. You can see that this is the row from see here. The AMA is here. And I and one of the office from Chinese National Science Foundation took a picture here just to certify that the Chinese government say I'm working here. Okay. You understand that this is also always required for the government level. Now everything you see that LCT cargo, the CSO cargo, in OSF already. This is the picture was taken something like in the middle of the May, just 1 month ago. We have a lot of cargoes here. This is base and it's here OSF, something like 3,000 meter, in altitude. This is, you see the picture here where this time, my colleagues and I went to the conception. It's mainly for the receiver. And then in the beginning of next month, we will focus on this mechanical work. Okay, in San Pedro. We will go to San Pedro next week. Actually, this is the new instrumentations enables new science. That's for zero the local. We call the local is less than 2. We have a lot of new instrumentations to do the science, and also even for high leadership, we have some very new challenge instrumentations listed here. I would like to show you this very good new instruments here. One is called Time. This is supported by the JPL from Caltech. It's very expensive one. They originally designed to be in a telescope SPT in Antarctica, but I don't know why they want to not want to install this instrumentation to LCT. This is line intensity mapping. It's very, very expensive. Something like several tens million. Okay, for this one. Also, the new music. We have we have 6 bands observations in the future. And this is I listed here is a instrumentation suite. You can find this for shock and for time and also for imaging and some spectral. Everything is here. And the first slide actually for time is already very successful in first slide receiver in the lab already. We haven't checked in test in a real telescope. Actually, this is our design for the future telescope. Is because it's in a plateau, it's very high. It's something like 5,100 meters in altitude. People cannot walk there for heavy work. We make this. We have to make this. Everything should be remote control. Okay, because the space is enough. So we just want to have the 2 tracks here to make this. We don't want to have something like a co-located dome. It's too expensive. We just like a garage-like things. When telescope is operating, and the garage will move back. Okay, when it's closed, it will move in. This will save a lot of money. But actually, I would like to say that the concrete, we haven't estimated the price of the concrete. In Chile, the concrete is very expensive. I don't know before. So maybe similar here, or the concrete, so still I have to fight with them. Actually, according to this lab, the FCT telescope, we established a very good lab for millimeter and submillimeter, because I know several of you were working on this, also for this kind of telescope. At the same time, we have this kind of a lot of expensive things here for to have a we call the ranking in the first among Chinese universities for millimeters and millimeter receiver. Now we're in ranking in the first top in Chinese universities. This is also some this SIS mixes and also kits or some this is dilution refrigerators. These kind of labs are always now it's charged by the guy. He's there. He's he's a young guy. Originally he's working here, working in the lab. He has done a good job. Currently, I push him a lot. Okay, still want to move forward. I'll show you some. This is what we have done in Shanghai and shipped to Concepcion, and then the Chilean guys make a test bed to see if we work very well. Exactly, luckily everything goes very well now. Okay, so for instance, we have meetings to be there to discuss a little bit in detail what we should do from Chile, because they had it's very hard for them to get a lot of things, some connectors or small things in Chile. We have to buy in China very easily, but we have to ship to Concepcion. But it covers a lot of money, for shipment. But the prices is in China is very 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 cheap, but the shipment, the fare for shipment is very very expensive. Okay, so finally, I would like to list here some LCD signs. That's very important for the future. Whenever a funding will support you, we will focus on science. LCD signs actually very close relate to the 10 of the 19th of Astro 10 2010 list for the discovery. A science frontier principle, questions, PQ questions, and 12.4 for discovery areas. There's many. Just let me summarize. It's something like this. For the local, we focus on the magnetic field and the star forming region, astrochemistry, some evolution. For the mid redshift, we focus on molecular cloud, SZ effect, and also high Z, something like that. Eventually, we can observe very high redshift, even we according to the carbon 2, this line carbon 2, just moving into the millimeter the band we can observe. That's the Yao period. Okay, so actually currently we decided to start because we are still lack of some a lot of people to working for this science. The middle science is not a lot of people working together. We are focusing on this TSE effect, thermal SE effect, and the KSE effect, kinetic, SE effect. And also, we want to do the survey for the star forming galaxies down to something like the 4 or 5. Even I'm writing here is 6 Milijansky level. Actually, we plan to have a 4 Milijansky level, something down to 1 solar mass per year. This kind of star forming galaxies, we have to want to have surveys. This will be very important for the input catalog for AMA. Because AMA, the field of view is too small. They don't have the input data. Okay, so this is a collaboration between LCT and AMA. Okay, so I think this is you can find this in US some US radio and some millimeter conference for that. Also, you can find everything. The main things is in the side of the ticket here. Okay, so that's all. I think I will stop here. That's all for my talk. Thank you very much. Thank you.
Thank you very much.
Who's class?
Awesome.
Oh, sorry.
I'm everywhere. This is mine too.
So any questions?
Questions? ¿Preguntas? Preguntas de las 3 charlas si quieren hacer, no hay problema. ¿Cómo? ¿Te alcanzó? Pueden hacer en español y yo traduzco cualquier cosa. Ah, sí, si quieren, intentamos. Si alguien quiere hacer alguna pregunta, les acerco el micrófono.
Yes. Is the question for me or for the other people? Okay, good.
Yeah, thank you for the talk. So, what kind of computational resources do you have available for machine learning and numerical simulations for galaxy
I
formation?
see. We have some a big Chinese Su Guang, something like a big GPU and the workstation, the very big one, is expensive. We can enough power to do that. Okay. So if you're interested, I will give you some for instance how many GPUs or running together at the same time simultaneously. I don't remember very clearly, but that's very efficient.
Thank you.
Yeah, for the Antarctic expert.
Peng, is he still here?
Yeah, I would like to know.
Yes, I'm here.
Yeah, if there is data on minor bodies, if they have made a catalog, we can access it.
I didn't get the message. It's
Data on minor bodies, moving objects in general, on your surveys from the Antarctic.
Yeah. So can we share the data we get in Antarctic?
Information of minor bodies from Antarctica. So I am wondering if you have the data, if you have published it, if it is available. If you,
Oh,
I don't
yeah.
know. If you,
Yes, we have actually we keep a time domain survey for over 10 years, and we have at least five catalogs for variable stars, exoplanets, something like that, published in APJ, AJ, this kind of genre. So sorry, because the presentation is very short, I did not go details into the scientific results. I just introduced the size and the instrument, the telescope. So if I think I can leave my email in the here. So if you want to get more information on the paper published, I can provide you some the scientific output.
Yeah.
Yes.
Yes.
Yes. You said that in China is cheap, and the cost to go to Changnan
Yeah.
is very expensive.
Yeah.
Do you have a site in Tibet to
Yes.
develop submillimeter
You
radius
have asked me
astronomy?
a very good question. Actually, I would like to say, China, we are starting our own, some millimeter telescope now close to Tibet, the Qinghai province. Just, found it. We found it, dig it at October last year. We're scheduled to finish in 3 or 5 years. Okay. But, actually, I would like to say, even within the whole China, that the quality, for the seeing for any some water evaporation, is cannot comparable to the Shanghai. No, it's much better. The Chilean is the good side, better side. But we're making that, we are building our own 15 meters. The LCT is 10 meters. So just we're trying to do that.
Are you aware that on the other side of the Andes, namely in Argentina, in the Argentinian side of the Atacama Desert,
Yeah.
there is a a very good site that I would say that is comparable to Chaknantor.
Oh, really? So, sorry for this is, for the motivation from my side, from me, for instance, is makes things much easier. Well, the site,
Yeah.
you understand that I
yeah.
don't want to waste a lot of time to to explore the where is which one is better size. But in the future, I think actually I would like to say in China, Chinese people want to establish want to make have to build this kind of even optical to radio to some millimeter telescope here because then although China is big but the size is not good. Okay.
Yeah.
For astronomy. So we are thinking about that. But maybe some political reasons or some, you know what I mean. That could be a problem. But Andes, Chile, is more closer to US guys, So we are doing together. Then we make us very safe. So you see that three parties: one is from China, one from US, one from Chile. Mixture together, make the things safe, and we can reach milestones.
Okay. And perhaps I missed the diameter of your
LCT?
Yeah.
10 meter.
10 meters.
10 meter.
Oh, okay.
10.4. But the most important is, it has the most accurate surface accuracy, something like 12 micron.
Uh-huh.
This is much, much better than AMA dish.
Yeah.
3 or 4 times. Yeah. This is very important.
Yeah. Well, in Argentina, there is in the province of Salta.
Yes.
There is a 12-meter telescope, but for millimeter observations.
Yes.
But it's on the ground at
Wonderful.
5,000 meters.
5,000 meters, okay. I
Yeah.
think it's also in Andes, right?
Yeah, on the
side of
Atacama Desert, the side of Argentina.
Easter. What's the receiver? The receiver you made by yourself or some
No,
guys?
no, it's a project that has been stopped.
Really? Why?
Yeah, because we have a government that is not keen of science.
So it's pity, actually. Yeah,
but the project was going on because the idea was to do interferometry with ALMA.
Oh, really?
Yeah.
That's good. That's good. That's very good. So I hope if anyone here for scientifically speaking to do research, you can contact me because we should need to maintain this kind of thing here. Also, especially for receiver guys or engineer. Okay. Okay.
¿Alguna otra pregunta? Well, thank you again.
Thank you very much.
And now we have coffee outside.
Coffee, you